Hello everyone. So today we are going to cover another interesting problem, rotate array. Unlike rotating linked list, rotating an array is quite a technical process because in linked list simply you can take a node from last and just put it in the front. But here it is not the case. So let's get into the problem. We are given an integer array nums and we have to rotate it by k times and send that as the result. So how are we going to do it? Let's understand this problem with an example. So here is our input given. Starting from the index last, it has to rotate it to the front. So first 7 will be rotated to the front and it becomes 7, 1, 2, 3, 4, 5, 6. And next time 6 will be rotated to front and it becomes 6, 7, 1, 2, 3, 4, 5. And finally 5 will be rotated and we will get 5, 6, 7, 1, 2, 3, 4. If we are trying to solve this by brute force, then we have to keep the last element's value in a temporary variable. So now let's temp is equal to 7. Try shifting the value from first index till last but one index to the second index to last. So now our array is going to become 1, 1, 2, 3, 4, 5, 6. And now we're going to assign 7 to our first place. So now this first place becomes 7. By that we done shifting our last element to first. Now again take the last element from this array and assign it to temp and shift everything else next, like 7, 7, 1, 2, 3, 4, 5, and finally assign the temporary variable to the first element. Now the first element becomes 6. Again repeat the same procedure, fix 5 in temp and shift everything else and finally find the first position. This is a straightforward solution, but it takes big O of n square time complexity. So how do we solve it in a better way? So the second approach is gonna have an extra array where this is of same size of our given array nums. We are going to assign the value from kth index, that is if a k is equal to 3, we're going to start from the third index and final index and assign those values first and then put all our rest values next. So by this way we can simply assign the values to an extra array and then return the values, but using an extra array will cause again big O of n space complexity. Though this actually done in big O of n time complexity, we still want to make it better by working this with constant space. So how do we do it? Our third approach is actually an analytically intelligent way to make this problem work. So now after rotating this by 3, this array is going to look, first 7 will be rotated and then 6 and then 5 and comes 1, 2, 3, 4. So if you observe this range 5, 6, 7, which is actually shifted from the last k range to the front, and then the rest of the range is just like that. So to do that, we are first going to reverse the complete array so that the second half range will come first and the first half range will come next. So let's reverse it. So it is going to become 7, 6, 5, 4, 3, 2, 1. And finally, we now got the second half to the front and the first half to the back. But we want it to be reversed again, that is, it has to be 5, 6, 7. But here, after reversing the complete array, it is 7, 6, 5. So what are we going to do? We are going to do this half alone a reverse and then this half alone another reverse. So this is going to become, if we reverse 7, 6, 5, it is going to become 5, 6 and 7. And 4, 3, 2, 1 is going to become 1, 2, 3, 4, which is actually our output. So this algorithm actually gonna work in big O of n linear time complexity, as this will be done in one pass and it is gonna have only constant space. since we are going to make this in a single array in place. So yes, so let's see how we're going to code it. So first step is going to be we are going to assign k's value k modulo nums.length. Why? Because if the k value is going to be higher than the length of the array, so the rotating reminders going to be the same. For example, if our array is 1, 2, 3, 4, 5 and our k is going to be 6, if we rotate it 6 times, everything is going to be reversed, and then one more time, like first 5 comes first in the first rotation, then 1, 2, 3, 4. Next rotation is gonna be 4, 5 and 1, 2, 3. Next is going to be 3, 4, 5 and 1, 2. Next is going to be 2, 3, 4, 5 and 1. And again it is going to be 1, 2, 3, 4, 5. So far we have done 5 rotations. So the fifth or sixth rotation is going to be 5, 1, 2, 3, 4. So now if you observe, it is similar to the first rotation we have done. Since both are same, if you rotate the same array again and again more than the length of the given array, it is going to be repeat the repetition. So in this case, we are simply reducing the case size by doing modulo. If you do 6 modulo 5, it is going to be 1. So our sixth rotation is going to be similar with our first rotation's value. So to avoid duplicate repetition of steps, we are just reducing the case value if it is greater than nums.length. So once that is done, we're going to have a helper method reverse to reverse our integer array. So you're just going to get our array n and starting value and an ending value. I'm going to have a temporary variable which is going to hold my start value, and in my end value I'm going to put my, in my start value I'm going to put my end, and in my end value I'm going to put my start value that is stored in temp. So once that is done, I'm going to increment my start and decrement my end. So this is simply a two-pointer solution where we keep 2 pointers at both the ends of an array and we just swap the elements as we move the pointer close to the middle. We simply going to call this function every time. First, to reverse our array nums from 0 to length. Next time we just gonna reverse the first half, that is first k. So from 0 to k minus 1 and k to length of the array. So yes, now our array will be completely reversed in place. Let's run. Okay, I'll pass here and there a few mistakes. Submit. So yes, our solution is accepted and it runs faster than every solution online. So thanks for watching. If you like the video, hit like and subscribe. Thank you.